Morning, everybody. Welcome to day 8 of Math 133. So today, we're going to do the Chapter 4 review worksheet. We're also going to talk about the Chapter 4 project survey. So it is worth points, but you'll have to do it on your own. So we'll just talk about it. But um, you're going to want to work on the 5.1 lecture notes. So those are due on Thursday, but try to have them done tomorrow because Elaine will be using that for Chapter 5, start of Chapter 5 worksheet tomorrow. I also put a note in here, don't forget to finish cumulative review number 1. So last week on Thursday, we started the cumulative review, and it's right here. And you'll notice that it's not due today, even though we talked about it last time. It is due on this upcoming Thursday. But we're going to finish it today. So we will do the Chapter 4 review, we'll do the Chapter 4 project, and then we will finish up the cumulative review. Okay. Um, so, I want to actually start today with the Chapter 4 project survey. Okay. So here I am in Canvas. If I click on the Chapter 4 project survey, uh, this is not, so this is going to be used on Thursday when we do the Chapter 4 project number 2. Okay. So we're going to be looking at distributions and stuff, but uh, all you have to do, so what we're asking you to do is submit the length of your forearm and your height, um, both of which we want measured in centimeters. Okay, um, so if you click on the link here in Canvas, brings you here, and so here's a picture of your forearm. So measuring from your elbow to your wrist, how far is that in centimeters? Um, and then so your email, your name, uh, what is the length of your inner forearm, and what is your height. Okay. So why are we asking for this? Um, so today we're going to be talking about Chapter 4. We're going to be doing the Chapter 4 review. Okay. And Chapter 4 is all about correlation, taking two quantitative variables, okay, and seeing if how they're connected. Okay. Is there a linear relationship between the two? So anyway, the projects as with any of the projects, they give us a chance to work with real world data. So um, when we were working on the Chapter 2 projects and the Chapter 3 projects, we were looking at I was looking at like a set of baseball data in StatCrunch. And then also looked at video game data, right? And for this Chapter 4 review, we're going to be working on using our own uh, data based on our own measurements. Okay. We'll get to do that again with a lot of the projects. Actually, near the end of October, around Halloween time, we're going to do a candy project where we're going to count M&Ms and Skittles, and we're going to actually go out and buy those and use real data. Okay. So as opposed to the worksheets where, okay, it's we try to use real data on the worksheets, but you know, those are more like chosen like based on what we want. Okay. You'll find that there's when you're working with real world data, there's often weird things that happen. You have to deal with those outliers. Okay. Versus on the worksheets, we try to make sure there's nothing weird. So anyway, go to Canvas, click on the uh link there, go fill out the survey. And submit it. I'll drop the link to the survey here in the chat as well. When you finish this, it's not going to show that you completed it in Canvas because this is a Google survey, and so it's not linked to directly to this. Um, so I have to go in and see who's filled out the survey. So don't worry if it doesn't show that you got those 10 points. If you filled it out, in time before Thursday, you get those 10 points. There's also a link right here that converts feet to centimeters, or if you want to convert inches. So if you measure your forearm in inches, you can convert that to centimeters, right? So 12 inches, convert that is 30.48 centimeters. Okay. So that's what you'd put right in here, right? Cool. All right. So as you can see on Thursday, we're going to use that data for the chapter 4 project number 2. Okay. Um, okay. Next, let's take a look at the chapter 4 review worksheet. And you're going to find that in your course pack on page 365. Page 365. There's 4 pages for the chapter 4 review worksheet. So we're going to work on that, and then we're also going to finish the cumulative review. So we're going to turn in 2 worksheets today. In Canvas, if I click on the chapter 4 review worksheet, it's going to bring me here. And then there is a link that brings us to that Google document with all of the different data sets. If I scroll down for chapter 4, the chapter 4 review worksheet is right here. And that's going to have a link to StatCrunch, because in there is going to have one of the questions that we're going to be working on. So make sure you, that way you don't have to type all of it in, right? You can click on that link. So once again, in Canvas, I clicked on the chapter 4 review worksheet. I clicked on where it says this link. I scrolled down to the chapter 4 review worksheet, and I clicked on where it says StatCrunch, and then I logged into StatCrunch. Okay. So we'll use that in a little bit. For the meantime, though, let's go to, that's not it. Sorry, my visualizer was stopped, it looks like. Uh, there we go. Page 365. Page 365 in course pack. Fill out your name. And just like all of our worksheets, I'll go through here and give you some hints, and then we'll stop the recording and we'll fill in the rest. Okay. Um, so uh, all of the stuff from chapter 4, uh, there is a really great summary in our exam notes packet. On page 253 is where the yellow exam notes packet starts. And we've talked about a lot of this already, but chapter 4 stuff is on page 255. Okay. So I'm just going to write at the top here, page 255. And that's where you're going to find pretty much all this stuff. So and again, I'm gonna mainly be giving hints on the ones that I think are a little more challenging. So I think questions 1 and 2, you guys should be able to answer no problem. Same with question 3. Um, and question 4, I think you're good. So let's actually jump to the next page, page 366. So, page 366, question number 5. Researchers want to know if food insecurity affects the teen birth rate in the US. So we gathered a random sample of states shown below. Okay. So these numbers here, we're going to be calculating a linear regression based on least squares. And we're going to be doing that using StatCrunch. So you can see that those numbers on page 366, they're all here in StatCrunch. So we're going to be using the method there, okay? We're going to be using StatCrunch to do all that for us, okay? So right here, the equation of the regression, okay? The way that you're going to do that is on page 255 at the top. To calculate a linear regression, we go stat regression simple linear. Okay. Page 255 at the top. Okay. Um, so once we've done that, that's actually going to give us D, E, and F. Okay. D is going to ask for the equation of the regression line. Remember that the equation of a line is y equals mx plus b. Okay. Where m is the slope and b is the y-intercept, right? We use the letter m for slope because slope has an m in it, and b for y-intercept because y-intercept has a b in it. That's just a joke. I have no idea why we use m and b. Slope does not have m in it, so that would, yeah, whatever. Anyway, so uh, StatCrunch is going to give it to you in the other order. That's fine. You can write y equals b plus mx. I'm fine with that. Either way is good. Um, but anyway, so the correlation coefficient, that's going to be r, okay? And the coefficient of determination is r squared. We talked about the correlation coefficient last week on Thursday. We messed around in StatCrunch, right? We were on that applet and we were looking at scatter plots for our project, and we were messing around making r, what happens if r is positive, what happens if it's negative, what happens if it's, close to zero, okay? Anyway, so part G down here, interpret, we remember what that means. It means we want a sentence in English, okay? So there is a script for this on page 255. Everything's gonna be on page 255 today. But there's a script. uh, There's a script right here at the bottom for the formal interpretation of the coefficient of determination. So you change it into a percent and you say this percent of the total variation in what's the y value, write out the name of the y value, is explained by the least squares regression line. Okay. So at the bottom, page 250. Okay. All right, so then part I here, based on the correlation coefficient, describe the direction and strength of the relationship. So just like on our project, uh, page 255, there's a number line there. Just like in our project that we talked about last week on Thursday, we were looking at this number line here. And based on what your correlation coefficient is, you can tell whether the relationship is strong or it's weak, uh, positive or negative. Keep in mind that the positive or negative just means the direction. It's the slope, it's related to the slope. So you can have a very strong relationship, but if it's negative, okay, it's still strong. It just means that as one thing goes up, the other one goes down. Okay. All right. Great. So next we have page 367. So continuing on with the data that we had before, um, the slope, the y-intercept, correlation coefficient, all of that stuff. Is it parameters or statistics? Again, that depends on whether you're looking at a population. So if you have the word all somewhere in there, then that means you have a population, or do you have a sample, right? And the slope, explain what it means in the context of the situation. So that all mean explain what it means in the context of the situation. Again, we want an English sentence there, and there is a interpretation of the slope on page 255 in the middle. So if x increases by 1, then y is expected to increase or decrease by approximately whatever the slope is, okay? So right here in the middle, page 255. Okay, script in the middle. All right, find the y-intercept of the regression line. So the y-intercept of a line, right, is where that line hits the y-axis. Okay, So that's your y-intercept right there. Keep in mind that a y-intercept is not just the b value, okay? So we said that equation of a line is mx plus b, and b is the y-intercept. Well, that's not entirely true. B is the y value there, okay? The y-intercept is 0, comma, and then a number, and that number is your b, okay? So when you write out your y-intercept, it's going to be 0, comma, something, okay? Now, the y-intercept of a line, when you're talking about regression lines, so what we're doing is, we have two quantitative columns, right? In this case, we have food insecurity and teen birth rate. And both of these are quantitative. They don't have to be continuous. They don't have to have decimals. They can be discrete, but you have two columns and we want to see how they're related, okay? So in other words, is there a formula that lets me calculate if I know this number, I can estimate this number, okay? That's ultimately what linear regression least squares allows us to do, okay? So when we're going to be doing the uh, project for forearms versus height, we're going to look at, uh, if I measure someone's forearm, will that give me an estimate for their height and vice versa, okay? You would think that someone who's very short is going to have shorter arms. Someone that's very tall is going to have longer arms, right? That's pretty common sense. Now, that's not entirely true, okay? And we'll see maybe we'll have some outliers, but for the most part, we should have a pretty good relationship between the two, okay? So for this one though, um, the y-intercept is when x is equal to 0. And oftentimes that is not going to make sense, okay? In the example with forearms and height, um, 0 would mean that someone has a forearm of length 0. Or if x is the height, someone has 0 height, okay? That doesn't happen. There's no way someone can have 0 height, right? You wouldn't even be like, yeah. So often, 0 does weird things, right? Usually when we're talking about least squares, the y-intercept is just a number, but it doesn't actually have much meaning, okay? Um, that's not always true. There are times that 0 is useful, and you have to pay attention because it depends on the context of the situation, okay? All that said, so the y-intercept, there's two interpretations. One is if it does make sense, and one if it doesn't. If it doesn't, you just say impossible for this to happen, okay? So it's impossible for a person to be 0 inches tall, right? So anyway, um, so there's two scripts there. You have to pick the right one based on the situation, okay? All right. New here. Okay, so find x, that's fine. Explain why the value above found above are most likely outside the scope of the model. So the other reason why 0 often doesn't make sense is because a linear regression uh, is is fine for data in a certain range. Okay, specifically we call it the scope of the model. Okay, remember when we were in StatCrunch and we were asked, okay, make a bunch of dots in a U shape. Okay. And we did that, and our R value was 0, or it was close to 0, right? Our correlation coefficient. And that's because when StatCrunch was trying to calculate a linear regression, was trying to draw a line through here, it couldn't do it. It was like, well, that line's terrible. This line's good for maybe these, but it's terrible for these. And um, so it couldn't find a linear relationship. On the other hand, if I was looking only at these points, okay, just these points right here, uh, I could actually draw a pretty good line through there, and that would be a strong negative relationship. On the other hand, if I was looking over here at these points, uh, these actually have a pretty good relationship. Maybe it's a moderate. I've got a couple of dots that are off that line, but I can draw, I can have a pretty decent linear relationship if I'm looking at a certain section of the data, okay? Specifically if I'm looking at the scope. Now, if I say, okay, here's my relationship, this only works for data from here up to here on the x-axis, okay? So that means over here, the x values down here, it just completely falls apart because these dots are way off of this line, okay? What I'm getting at is that when you're doing least squares, when you're doing linear regression or linear predictions, those work great for small ranges, okay? And if you go outside that range, things fall apart quickly, okay? Not always, but usually. Uh, okay. So that's fine. That's good. Let's go to last page, which is page 368. So Alaska equals X, find Y, interpret both values in the context of the situation. Okay. Um, it's fine. Um, find the residual. So residual is on page 255. No surprise there at the bottom. Residual is your actual Y value minus your predicted Y value. Okay, and it can be negative, that's fine. Um, Actual Y is the number that they give you. Predicted Y, you'll notice there's a Y hat here. That just means it's a prediction. So the predicted Y, you have to use your formula and calculate. Okay, and then you subtract those two. Okay. All right. The last one down here, fill out the correlation diagram. So here we're going to have our x variable, which is our independent variable. You're going to have your y variable. You're going to write what that is here. Okay. And and then you're going to label each of these arrows. So this one is correlation, causation. This one is also causation. Causation. So, but you might have a correlation between your X and Y. Maybe it's a strong correlation. Maybe it's moderate. Maybe it's negative. Maybe it's positive. Whatever it is, you might have a correlation between the two. That doesn't necessarily mean that uh, this causes this to happen. Okay. So in other words, uh, we were talking about like height, and so if you are very tall, that doesn't necessarily mean your height causes your arm to be long. Okay, there's just a correlation there. Okay, so there are sometimes correlations between things that are misleading. Okay, and so you cannot just assume that because there's a correlation that there's some kind of relationship that actually is driving things, okay? Because there may be what's called lurking variables. And I want you to list out at least one lurking variables, at least one lurking variable in this situation, okay? All right. So, Aline, I think they got rid of that comic, the one about the ice cream and the crime. I liked that one. So I thought that was going to be on here, but it's not. So it was a good,
No, and I
it
don't like
was,
those diagrams.
oh yeah, but
I
I liked that
don't like,
example because that example was a good illustration of why causation does not mean or correlation does not mean causation. So anyway, okay, so that all said, Make sure you work on the chapter 4 review worksheet. I'm going to stop the recording here and we're going to go back through and fill everything in.